Let us discuss this concept interval. We have already seen open interval, closed interval, but let us see what is the definition of interval. Basically, it is a subset of R which satisfies certain condition. So that condition is, if we have A, B belongs to I and A less than X less than B, then X is also member of I. So this is definition of interval. That means if any two point lies in a set and if you select any point between these 2 points, then again it is a member of same set. I will show you here. For example, suppose your I is equal to open interval 2, 7. So suppose this is 2, 3, 4, 5, 6, 7. So this is open interval. Okay, so basically it is an interval. If you select any point 3.2, if you select any point 3.2 between 2 and 7, 100% that point is again member of I. 3.2, 5.6, whatever the number you can take, but the number should be between 2 and 7, then again it is a member of same set. Then we can call it as a interval. Okay, so I will give one example which is not an interval, that thing also. Second, suppose A is equal to 2, 3, 4, 5, 6. This is a set. Getting this is a set having how many numbers are there? Just 5 numbers are there. 2, 3, 4, 5 and 6. So see here 2.7, okay, 2.7 lies between 2 and 3. Lies between 2 and 3, but 2 and 3 are elements of this set and 2.7 lies between 2 and 3, but 2.7 does not belongs to A, since A has only these 5 elements. Getting, so that means if you select any 2 points of a set, the point between them does not belongs to the same set, so therefore I is not an interval. Therefore, sorry, A is not an interval. I hope all of you understood. You are already understood the meaning of interval, but the mathematical definition is this one. If you select any 2 points, then the point between these 2 points again in a same set, same interval. Okay, so then we can call it as an interval. Okay, make a screenshot of it. After that, we will discuss one more concept. See, the next concept is epsilon neighborhood. Epsilon means a very small positive real number. Okay, epsilon neighborhood of any point. So for that we need to have one point. I have taken P here, and epsilon is any very small positive real number. Okay, then epsilon neighborhood is defined in this way. And P epsilon is equal to, see, I am writing its mathematical definition. It is X belongs to R such that mod X minus P less than epsilon. See, in a simple words we can say epsilon neighborhood means it is a collection of points having distance from P is less than epsilon. That means points which are very close to P. Getting, when we say we call the people to our neighbors when they are very close to us, getting, or very close to our, they live very close to our home. So see, same thing is here. It is a collection of points which are very close to point P. Suppose point P is here. The points which are very close to P, we call it as a members of this set. Let us simplify it. So this is X belongs to R such that, you know that there is one result I will mention here, mod A less than B if and only if minus B less than A less than B. So we have seen this. Okay, let us use it here. X minus P is A and epsilon is B. Minus epsilon less than X minus P less than epsilon. See, I am going to add P on all sides. I am going to add P. So therefore, P minus epsilon less than X less than P plus epsilon. Getting, so it is a collection of points which lies between P minus epsilon and P plus epsilon. That means this is nothing but interval P minus epsilon, P plus epsilon. So P minus epsilon will be here, P minus epsilon, and this is P plus epsilon. So this is an interval having center P and radius epsilon. So that means points which are very close to P. So that is epsilon neighborhood of P. If you take small epsilon, you will have a very small interval. If you take large epsilon, we will have a large interval. But see, epsilon means a small positive real number. No, so normally we take a small interval, small epsilon. Okay. Make a screenshot of it. Then we will discuss one more concept. See, the next concept is deleted epsilon neighborhood. It's a very simple concept. You are already familiar with epsilon neighborhood. What we do, we simply remove the center of neighborhood from a neighborhood. That is a deleted epsilon neighborhood. So see, we have a point P, we have a epsilon. So you are familiar with epsilon neighborhood of P. Get it? So simply we remove point P from its neighborhood. And we can call it as deleted epsilon neighborhood. If you draw the diagram, it will be like this. Getting? So this point P, but it is removed. So that's why I have shown here empty, okay, blank. So this is P minus epsilon and this is P plus epsilon. P is removed. So that's why I have not shown it here. Getting? So this is called deleted epsilon neighborhood. That means the center is removed from the neighborhood. Okay. Make a screenshot of it. After that, we will discuss few examples. So let us solve these two examples. Okay. So we have to find epsilon neighborhood of some point with given value of epsilon. See, we will focus on the first example. In first example, what is a point? So the first point 2, P is equal to 2, and the second number denotes the value of epsilon. Epsilon is equal to 1. So we have to find epsilon neighborhood of 2. Getting? Epsilon neighborhood of 2, point is 2 and value of epsilon is 1. Let us solve. See, I am going to follow the definition. So definition says x belongs to R such that mod x minus P, P means 2, less than epsilon. But what is value of epsilon? 1 here. This is equal to x belongs to R. Okay, so I am going to apply that result, mod A less than B. If and only if minus B less than A less than B. So by that result, minus 1 less than x minus 2 less than 1. Can you guess the next step? Obviously, I am going to add 2 in all sides. So 2 minus 1 less than x minus 2 plus 2x, 2 plus 1. So this is equal to x belongs to R such that 2 minus 1, 1 less than x less than 3. So we get interval here 1 comma 3. Getting? So see, this is 0, 1, 2, 3. So the point is 2. Given point is 2. And what is the neighborhood? What is value of epsilon? 1. So 1 on that side, 1 on this side. So this interval we get 1 comma 3. Let us solve the second example. In second example, what is value of P? P is equal to 1.5 and what is value of epsilon? It is 0.5. So this is equal to, again I follow the same definition, x belongs to R such that mod x minus 1.5 less than 0.5. Okay, x belongs to R. I am using the same definition. Value of P is 1.5 and value of epsilon is 0.5. Let us use the same that result. So we can write minus 0.5 less than x minus 1.5 less than 0.5. After that, I will add 1.5 in all sides. I am adding 1.5 in all sides. So 1.5 minus 0.5. If you add it here, plus 1.5 minus 1.5 will get cancelled to each other. So less than 1.5 plus 0.5. So this is equal to x belongs to R. 1.5 minus 0.5, 1 less than x less than 2. Getting? So we get an interval here, open interval 1 comma 2. So you can see here 1, 2, 3, 1. What was the center? Center of interval is 1.5 and the value of epsilon is 0.5. That means 0.5 on this side, 0.5 on that side. So if you come 0.5 on this side, 0.5 plus that side, so we get an interval 1 comma 2. In this way we solved second example also. Make a screenshot of it. After that we will stop. Thank you. Bye bye.